Hello friends, today it is about tides. Through animations, let us understand what are tides and how are they formed. It's a fact that two-thirds of the Earth's surface is covered with ocean. That is, nearly 70% of its outer surface is water. And we have a beautiful neighbor, the moon. And it is observed that due to the presence of the moon, two bulges at these points and two contractions at these points are formed, and these bulges are always along the line connecting the moon. And our earth is spinning on its own axis. So what happens if we stand on the spinning earth somewhere here? Remember, bulges are always along this line connecting the moon. When we are here, we find that sea level is highest, and when we reach here, we find the sea level lowest, and again high here and low here. So, when the earth completes one spin or in one day, we find that the sea water rises and falls two times. This phenomenon of rise and fall of water level is called sea tide. Now, what could be the reason for this? Well, this is one of the most misunderstood topic in physics. Many resources, including textbooks, say that the nearest bulge is due to gravitational pull of moon and the farthest bulge is due to centrifugal force or inertia. You know, the gravitational pull by the sun on the earth is approximately 180 times higher than that by the moon. So, if direct gravitational pull was the reason for this bulge, then it should be towards the sun and not towards the moon. And the reason for the farthest bulge, according to many, is related to the Earth Moon rotation system. In a general sense, we say the moon is revolving around the earth, but actually, both are revolving about a common point called barycenter, and this point, in fact, lies at this portion of the earth. That means the earth is also revolving around this point, and this can give rise to centrifugal force in this direction here. That same centrifugal force which tries to throw you out of the car when taking a turn. So, the water will be thrown out here, and that can create a bulge here. Sounds convincing, right? That is why even some textbooks have this as the reason. But the fact is that the revolution of the Earth Moon system is so slow that it takes 27 days for one full rotation, and the force generated due to this is so less that 1 lakh times of this force is required to cause any rise in water level. And another point, as per this theory, at these locations, water has to be displaced in this direction, but actually, water is displaced in this direction here. Never mind if we could not understand that portion properly, because that is not the actual reason. Then, what is the real reason? In fact, both the bulges are caused due to the way in which the gravity of moon acts on earth. Confused? Please stay with me for a few more minutes. This is nothing complicated. At the end of this video, you will be able to explain to anyone the actual reason for tides. Here we go. When we say there is a gravitational force between the earth and the moon, it means that the moon is also exerting or pulling the earth with equal force. For a global understanding about the motion, we can consider this force as acting at the center of mass of the earth. But if we want to find what exactly it does to earth, then we have to consider the forces acting on different regions of earth. And are they equal? Well, gravitational force always reduces as the distance increases. So, the force is highest here since this is the closest point to moon, medium here and smallest here. The forces at different parts look like this, and all these forces are always directed towards the center of the moon. So, this is the force distribution. One way to look at the effect of this force distribution is like this. This force should displace the objects here more, and this lesser, and this still lesser, and we get a shape like this. But there is a catch here. What we have shown here is the total force which also causes the moon to orbit around Earth as a whole. We can always assume that part of force acting at the center. Okay, that means the force acting at the center is what causes the moon to orbit. Then we can note that here net force is higher than that at the center and here it is lower. So, for isolating that force and to clearly understand the shape changing part alone, we can subtract all these forces with the force acting at the center and it looks like this. So this is the distribution of the force that create bulges and these are called as tidal forces. And it is obvious that it creates bulges here and contractions here. These are called tidal bulges. And what happens here? The tidal force is in this direction and due to this there is a tendency for one layer of water to slide over the layer beneath and that also adds to the bulges and contractions. Is it only the water that gets displaced or solid particles too? Well, the solids have a definite shape and higher force of attraction between them. And we can see here when I tilt these two glasses, the water in the glass immediately changes shape whereas the shape of sand remains intact. So, land mass has a capability to retain shape and so the bulges produced on land area are so small compared to that on water bodies. Then, what would happen here where the land meets sea? The tidal bulges would be along this direction, and here sea will bulge and land will not. So, seawater will rise above mean level. And when this part of the earth reaches here, sea will contract and will go below mean level. This is the common effect of tides that we generally see. Now, what about the sun? It is such a massive body when compared to moon. Still, we are talking only about the moon. Why? Well, the answer lies in the reason for tidal forces. It is the difference between the gravitational forces at the closest and farthest points that matters, and not the magnitude of force. The gravitational force exerted by the sun on the earth is very high, in fact, around 180 times compared to the force between the earth and the moon. But the difference between the forces at these two points is much lesser when we compare with those produced by the moon. Why? Well, the sun is 1496 lakh kilometer away from the earth and the moon is only 3.84 lakh kilometer away. That means in the case of the sun, the distance is much higher when we compare with the size of the earth. This is what matters. Let us say the sun, the earth and the moon are aligned like this at a particular moment and let us see how the force varies. Force exerted by the sun on the earth varies like this and that exerted by the moon on the earth varies like this. In the case of the sun, this is the closest point and this is the farthest point and this is the difference between forces which cause tidal bulges. And when moon is here, this is the closest point and this is the farthest point and this is the difference between forces. In the case of the sun, we can see that the difference is small even though the value of force is high. So, tidal forces would be small, but even though small, they are still there. What is the direction of the tidal bulges produced by the sun? Well, it should be directed along the sun like this. Now, what would happen when the sun, the moon, and the earth get aligned like this or like this? The moon would try to produce bulges here and the sun would try to produce contractions. That means they oppose each other and overall tidal effects would be minimum. These are called as Neap tides and the moon takes 28 days for a complete revolution. So after 14 days, the moon completes half a revolution and reaches here. Again, Neap tide happens and so Neap tides happen once in 14 days. And what would happen when they are aligned like this or like this? Well, The moon produces bulges here and the sun also produces bulges here, and the effect becomes maximum, and those are called as spring tides. And these also happen once in 14 days as the moon reaches from here to here in 14 days. And when the moon is at this location, it is new moon, and here full moon. So, scientifically, something special is happening in terms of tidal forces during full moon and new moon. And one last point. So far, I have been telling you that the tidal bulges are always along the center line. Is it perfectly so? Let us see. We know that the earth is spinning and seawater is also spinning along earth. When the seawater reaches here, it experiences the peak tidal force, and under the action of this force, it gets displaced. But by that time, due to spin, it moves away from the center line also. So, the peaks of the bulges slightly lag the center line like this. That's all for today. So, next time, when you happen to hear the wrong explanation, confidently offer the correction. Do subscribe and stay with us. See you soon.